Good day, good people. um, Let us do the revision on kinematic. Okay, a ship, a ship that can cruise at 67 kilometers in still waters set course. Now we are given the coordinates. This is north, east, south, west. We know that north it is 90 degrees, 0 degrees it is east. South it is 270, west it is 180. This ship it is going northeast. It is between these cardinal points. It's between, that means it's on the 45-degree angle because 90 divided by 2 is 45. We know that our quads are made up of 90, 45, 45. The ship at what speed? At 67 kilometers per hour. It is driven off course by a current flowing east. East is your reference point. South, it is the angle of deviation. It is 20. Now it is flowing that direction. East, we are told that current flowing east. Now east, it's my reference point. Then I would write everything on the same Cartesian plate. 21. Then we know that our quads are made up of 90. Now 90 minus 21, it will give us what? 69. Right. That's your 0 point. We'll be using the vertical component method, but we'll use it as I've showed you. We know that vertical component, they are made up of sine, and the horizontal component, they are made up of what? Of course. This method, it is one and the same thing as your resolving method. You can use the resolving method, you will get the same answer. But for the sake of those who didn't do N2, N3, and all that, now I prefer teaching the resolving method in this way. Now, whenever we look for vertical components and horizontal component, we will start at 0. We are looking for vector. What is a vector? Vector, it has two things, magnitude and direction. That means we'll be looking for the magnitude of the vector and its position. We start at 0 looking for those vectors. Now, 0, boom. We found our first vector. The magnitude of it, it is 67. The position, it will be sine 45 plus. Then we start all over again. We look for another one if we have 0, 90, 180, 270. Boom. We found our second vector and they said it is 17 kilometers per hour. Now, the magnitude of our second vector, it is 17. Its position would be sine 270 plus 69. It gives us 339. That means the position here, it is 339. Boom. Then when coming to horizontal component, where we have sine, we'll put cos, but we'll write magnitudes as they are. We are having 67 cos 45 plus 17 cos 339. Okay. Then our components would be 67 sine 45 plus open bracket 17 sine 339 close. Then I get my vertical component and it's a positive one. The coefficient of it, it is positive. I get it as 41,283 kilometers per hour. Then Where the sign, we will put what? We will put cos. It will be 69 multiplied by cos 45 plus open bracket 17 multiplied by cos 339 close bracket. Then I get my cos as a positive 1 as well, 63,247 kilometers per hour. Right. Now that's what we calculated. The coefficients. Now the coefficients of your components, they are positive. That indicates to you that your resultant, it's on the first quad. Now, we will then first determine the resultant, then we will do the second Cartesian plate in drawing the position of your resultant, because you don't assume it, you always work it out. Now, my resultant would be square root VC squared plus HC squared equals to 41,283 squared plus 63,247 squared, all square root. Then we get our resultant as what? Sorry about it. 41,283 squared plus 63,247 squared. Right, I get my answer as 75,528 kilometers per hour. Right. Now, in calculating, we've calculated our magnitude as per the equation. Now, in calculating the direction, we did indicate that our resultant would be on the first quad, because all forces going up, or the direction north, it is positive, the direction east, it is positive. Now, the VC, it is positive going north, and of which it is 41,283. Then horizontal component, it is positive. Where it is positive, it is when it is going east, it is 63,247. This is where your resultant would be. Whether you calculate alpha or theta, it doesn't matter. At the end of the day, you need to apply. Let's calculate the theta. It will be tan theta equals to 63,247 divided by 41,283. Now, it is opposite over adjacent. Our tan, it is made up of opposite over adjacent. Then tan theta would be the inverse of tan 63,247 divided by 41,283. Then we get our answer as the inverse of tan. We get our answer as 63,247 divided by 41,283 equals 2. Right. Now I get my answer as 56,866 degrees. But we will be applying the given principle. The given principle says you will start with the cardinal closest to the vector first. Now, this angle that we have calculated here, it is 56,866. But we know that our quad, it is made up of what? Of 90. Now, when you minus that from 90, then this angle, it is 33,134 degrees. Then you ask yourself, my resultant, it is close to east or is it close to north? It is close to north. Now, in writing your direction, it will be resultant equals to 57,528 kilometers per hour at north 33,134 degrees east. This is the given principle. But the fact that your resultant occurred on the first quad, it doesn't matter whether you write it as east 56, comma 866 north. Now, the point of reference would be east, angle of deviation, then the other cardinal point. You will still be marked correct because everything occurred on what? On the first quad. And we know that our quads are made up of what? Of 90. You will still be marked, you will still be given the full marks there. This is how we tackle question number 1. Okay, let's look at the second question there. Let's look at the second question. On the second question, they want us to calculate the displacement. I will just wipe here so as to tackle the second question. They want us to calculate the displacement in kilometers after 15 seconds. Now, we have already calculated VR, then we are having S over T. We are given time, we want displacement. We'll make displacement the subject of the formula. It will be VR multiplied by T. Then our VR, we did calculate it. It is 75. Sorry about that. We did calculate our velocity there. It is 75,528 kilometers per hour multiplied by 15 hours. Bases are the same. What do we do with exponents? We add them. Anything to the power 0 equals to 1. Now it will be 75,528 multiplied by 15. Then we get our answer as our displacement. It is 1,132,92 kilometers. Right. This is how you tackle this equation. Okay, let's go to the second one. On the second question, two vehicles, this is a relative motion. Two vehicles starts moving simultaneously at the fork. Now we'll be applying the same method, okay? We'll be applying the same method, the vector method. We'll solve this by using one method, the vector method, okay? By using the vector method. Right. This is 90, 0 degrees, 180, 270. 360 revolution. It is completed. We'll write everything on the same Cartesian plate using the same method, the vector method, okay? Two vehicles starts moving simultaneously at the fork on the road. Vehicle P travels at the speed of 80 kilometers per hour northeast. Vehicle P, this is where it's going. Vehicle P, it's going northeast. We said it that our quads are made up of what? Are made up of 90. Now northeast, it will be what? It will be a 45 degrees. That means this is 45, 45. VP at what speed? 80 kilometers per hour. Right. Simultaneously, meaning they move from the same point in going in various places. Simultaneous, same point, the point of departure, it is same, and they depart from the same point going in various direction. Now let's depict the second vector there. Vehicle B also travels at the speed of 80 kilometers per hour but directly east. P, it is heading that direction at the same speed as well. VB, I mean to say, at 80 kilometers per hour. Right. Now, they say calculate the velocity of vehicle P relative to We know that if we are given such statement, calculate the velocity of vehicle P relative to, right? You will stop P. This is the indication that stop P in its position and reverse vehicle B in an opposite direction. Now, we will reverse. I would use a black color to reverse. We have reverse. We will reverse VB. VB now it is heading west at 80 kilometers per hour. Right. Now we not want to be using this one. Right. Because we stopped and reversed. Now in calculating the resultant in magnitude and direction, like I said, we'll be using the same method. Vertical component. We are looking for the magnitude of the vector and its position. Now, 0, boom, we found our first vector there. It is the magnitude, it is 80. Position, it is sine 45. Plus, we start all over again from 0. We look for another. Boom, 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 boom. We found our second vector. The magnitude, it is 80. Its position, it is what? It is sine 180. Then we can calculate our vertical component. Then when coming to the sum of the horizontal component, where does sine we put cos? Cos 45 plus 80 cos 180. All right, then we get our answers. Okay, let's do that. 80 multiplied by sine 45 plus open bracket 80 multiplied by sine 180 equals 2. Now I get my answer for vertical component as 56,569 kilometers per hour. Okay, then for horizontal component, it is 80 multiplied by cos 45 plus open bracket 80 multiplied by cos 180. I get my answer as negative. My answer here it is negative 23,431 kilometers per hour. Now, the coefficient of your components, they will indicate to you where will the position of your resultant be. Now, all forces going up, they are positive. All forces going towards east, they are positive. All forces going towards west, they are negative. South, negative. Now, when you look at this components, you can tell that the vertical component, it is heading north, and the horizontal component, it is heading west. It means this is where your resultant would be. This is the position of your resultant on the second quad. Right. Our resultant, it's on the second quad. What indicated for us, it is the coefficients of your components. The vertical component, it is positive, it's going north. Horizontal component, it is negative, it is heading west. Now let's calculate the resultant. In calculating the resultant, it will be VC squared plus HC squared. Then we get our answer as 56,569 squared plus 23,431 squared, all square root. Then we get our resultant as well. 56,569 squared plus 23,431 squared. Now I get my resultant as 61,229 kilometers per hour. Right. That's what we got there. This is our answer that we got there. Then we can either calculate alpha or theta. By now we know it doesn't matter. We will be applying the given principle. And the principle says you start with the cardinal closest to your vector first. But it doesn't matter. You can make east the reference point or you can make west the reference point, as long as you are within the 90 of that quad. It doesn't matter. Now in calculating, it will be tan. We will calculate tan, let's say tan alpha. Then it will be 23,431 divided by 56,569. Let's somewhere say the inverse. By now we know how to. It is alpha equals to the inverse of tan. Then we get our direction as 23,431 divided by 56,569. Right, we get our angle as 22,499 degrees. Now, then we ask ourselves, our resultant, it is close to which cardinal point? It is close to north. Now, it will be north 22,499 degrees west. Or we can make west our reference point. That means it will be west. We minus that from 90. Then we get 69. Then it will be west. If we make west our reference point. Now what did I do then? If we make west our reference point, then it will be west 67,5 degrees north. You will still get full marks if you wrote it this way. Whether you write it this way or this way, it doesn't matter. You are within the second quad. This is how you tackle that question. I've used one method. I didn't use the other method, okay? Just to save time and to save you all the trouble of using a lot of method and getting yourself confused. But it is good to have all methods, okay? Now let's look at this one. A shell is fired with the muzzle velocity of 290 at. Now here we are dealing with projectiles, horizontal projectiles. This would be your height, this would be your maximum L. Initial velocity is 290 meters per second. The angle of projection, it is 29 degrees. Right. Now, they want us to calculate horizontal displacement. Like I said, how the equation you will indicate for you which formula to apply. They want us to calculate the horizontal displacement. It means we will be using this method S equals to U cos alpha time, because we are given time. What is our initial velocity? It is 290 multiplied by cos 29 multiplied by 6 seconds. Then we get our displacement as what? 290 multiplied by cos 29 multiplied by 6. Now we get our maximum displacement as 1521. 290 times cos 29 times 6. Yes. We get our displacement as 1521,838 meters. Right. That's what we got there. Then they want us to calculate the vertical height. Now, they are indicating to us that which formula to use. It will be height equals to u sine alpha multiplied by time minus 1 over 2 gt squared. This is the formula that we'll be using. It will be 290 multiplied by sine 29 multiplied by 6 minus 1 over 2 multiplied by 9,8 multiplied by 6 squared. Then we get our answer as what? 290 multiplied by sine 29 multiplied by 6 minus 0.5 multiplied by 9,8 multiplied by 6 squared. Right. We get our height as 667,169 meters. Right. You can calculate your height as well using u squared over 2g sine squared alpha. You can. It will be 290 squared over 2 times 9,8 multiplied by sine 29. Is it 29? Yes, 29 squared. Let's see if we will get the same answer. Right. Please check for me if you are getting the same answer or not, or they are specific that we need to use that one of time. Okay, now this is how you tackle this question, good people. Then I will be posting I will post other questions, but for now go through this video, check question 1, question 2 and question 3. Then I will post other question regarding our revision. Thank you, good people.